distribution of electrons in orbits. Let us now see how these electrons are organized. According to Bohr, electrons move in the stationary orbits or shells, which are associated with a certain amount of energy. The orbit closest to the nucleus is given the number 1, the second orbit the number 2, and so on. They are also named as K, L, M, N, corresponding to the shell numbers n is equal to 1, 2, 3, 4. The number of maximum electrons in each orbit is given by a formula 2 multiplied by n raised to the power 2. The following table gives the maximum number of electrons in each orbit. The K shell can have a maximum of 2 electrons. The L shell can have a maximum of 8 electrons. The M shell can have a maximum of 18 electrons, and the N shell can have a maximum of 32 electrons. Electronic configuration of elements. The arrangement of electrons of each element in their orbits or shells is known as its electronic configuration. You have seen that K, L, M, N shells occupy 2, 8, 18, 32 electrons respectively. Every electron has a fixed amount of energy depending on which orbit it is present in. Electrons in the first orbit, that is, K, have minimum energy. Electrons in the subsequent orbit possess higher energy. Electrons in an atom occupy shells in increasing order of energies. Let us see the electronic configuration of atoms of some elements. The number of electrons present in the hydrogen atom is 1, and the electronic configuration is 1. The number of electrons present in the helium atom is 2, and the electronic configuration is 2. The number of electrons present in the lithium atom is 3, and the electronic configuration is 2, 1. The number of electrons present in the carbon atom is 6, and the electronic configuration is 2, 4. The number of electrons present in the nitrogen atom is 7, and the electronic configuration is 2, 5. The number of electrons present in the oxygen atom is 8, and the electronic configuration is 2, 6. The number of electrons present in the fluorine atom is 9, and the electronic configuration is 2, 7. The number of electrons present in the neon atom is 10, and the electronic configuration is 2, 8. The number of electrons present in the sodium atom is 11, and the electronic configuration is 2, 8, 1. The number of electrons present in the chlorine atom is 17, and the electronic configuration is 2, 8, 7. The number of electrons present in the argon atom is 18, and the electronic configuration is 2, 8, 8. Atomic number and atomic mass number. Let us now understand some important terms. Atomic number Z is the number of protons present in an atom. An atom of an element is electrically neutral. The number of protons and electrons are equal. Atomic masses are measured in a unit called Dalton or U. A Dalton is approximately equal to 1 atomic mass unit or AMU, or AMU, which is equal to 1.6 multiplied by 10 raised to minus 27 kilograms. The mass of a proton, neutron and electron is approximately 1 AMU, 1 AMU and 0.0055 AMU respectively. So students, you can realize how less the mass of electron is as compared to the masses of proton and neutron. Hence, when calculating mass of an atom of an element, we only add up the mass of proton and neutron. The atomic mass of an element is equal to the sum of the number of protons and neutrons present in the nucleus of the element. It is called the mass number and denoted by the symbol A. The atomic number and mass number of an element can be represented symbolically as, for example, sodium 2311.